Hello, I am here with a new chapter of set theory, that is relation. So let's get started. Whenever we say a relation, there will be two people. It's about two people, that is a relation between a mother and her child, a relation between a teacher and her student. So likewise in mathematics, whenever we say a relation, it's about two non-empty sets, that is A and B, and you will have to find out Cartesian product of this two non-empty set, that is A cross B, and the relation is defined to be the subset. If the subset is denoted by rho, then the subset of A cross B. A relation is defined to be a subset of A cross B. So, if rho be a subset of A cross B, rho is said to be a relation. How can we find Cartesian product or cross product of A and B? Suppose A is a set like this, A, B, C, D, and B is a set like this, E and F. So, you have to find A cross B. Then A cross B is the set of all ordered pair like AEAF, BEBF, CECF, DEDF, that is AE ordered pair, and AF, BEBF. Similarly, CECF, and finally DEDF. These are the all ordered pair. So this is A cross B. Suppose I am taking out a subset from this A cross B, that is rho, like that AE, BE, CF and DF. So this subset is said to be a relation. Since AE, this ordered pair belongs to rho, that is AE belongs to rho, then we will say A, the element A is related to the element E with the relation rho, and we write it as A rho E. And if the element does not belongs to rho, then we will say like you will find AF does not belongs to rho, that is AF does not belongs to rho, and we will say that A is not related to the element F with the relation rho, and we will say that AF does not belongs to rho, and we will write it as A rho bar F. By the way, myself Dr. Ruchira Choudhury, and you are watching me on Infinity Math, which is a newly opened channel. So subscribe my channel and stay connected with my WhatsApp channel, also with the Telegram channel, whose links are provided in the description box. Now I am giving you a simple example of a relation. Suppose S be a set like this 3, 4, 5, 6 and T be a set like this 10, 11, 12, 13, 14. Now rho is defined to be like that. ST will belong to rho if and only if S is a divisor of T. That is, the first component of the ordered pair ST will be a divisor of the second component of the ordered pair ST. So in taking that the elements of rho, I will notice that the 3 will be a divisor of which of the elements of T. So for taking the elements of rho, we will have to notice that 3 is a divisor of which of the elements of T. That is, 3, 10 will not belong to rho because 3 is not a divisor of 10. But 3, 12 will belong to rho because 3 is a divisor of 12. Similarly, 4, 12 will belongs to rho because 4 is a divisor of 12. In that way, I will collect the elements of row, and this is a proper subset of S cross T. S cross T contains all the elements of ordered pair, that is from taking the elements S and T, but row is the subset of S cross T, that is the proper subset of S cross T. So, row is a relation. Now it's time to know about binary relation. In case of binary relation, there will be only one non-empty sets, that is S, and you will have to find out S cross S, that is the Cartesian product of the set with itself, and the binary relation row is defined to be the subset of S cross S. So, a binary relation row on S is a subset of the Cartesian product S cross S. Let's come to the definition of a equivalence relation. Now, what is an equivalence relation? A relation is said to be an equivalence relation if it is reflexive, symmetric and transitive. Now, we will have to know what is a reflexive relation. So, if let S be a non-empty set and row be a binary relation on S. Now, row is said to be reflexive if AA belongs to row for all A in S. That whenever AA belongs to row, we will write it as A row A, and A row A holds for all A belongs to S. This is the symbol of for all, and so A row A holds for all A belonging to S. So, row will be said to be reflexive if AA belongs to row for all A in S. Now, let us know the definition of a symmetric relation and a transitive relation. A relation is said to be a symmetric relation if AB belongs to row implies BA belongs to row. That is, AB belongs to row means A row B holds, A row B will imply B row A, and this will be said to be a symmetric relation. A relation is said to be a transitive relation if AB and BC belonging to row together imply AC belonging to row. That is, A row B and B row C will together imply A row C. So, if a relation is reflexive, symmetric and transitive, that is R for reflexive, S for symmetric and T for transitive, then this relation is said to be a RST relation or equivalence relation. Now, I am giving you an example to clear our conception for the definition of reflexive, symmetric and transitive. So, where is the example? A relation R is defined on the set A 1, 2, 3, 4 by R equals to this. We have to test whether R is reflexive, symmetric or transitive. Now, what is R? The set R is the subset of A cross A. A is 1, 2, 3, 4. Now, we have to see whether R is reflexive or not. Now, R will be reflexive if the ordered pair 1, 1, 2, 2, 3, 3 and 4, 4 all belongs to R. But you see, the ordered pair 1, 1 belongs to R, the ordered pair 2, 2 belongs to R, the ordered pair 3, 3 belongs to R, but the ordered pair 4, 4 does not belong to R. So, 4, 4 does not belong to R. That is, ARA does not hold for all A belonging to capital A. So R is not reflexive. Next we will test whether R is symmetric or not. Now R will be symmetric if AB belonging to R implies BA belongs to R. So 1 3 belongs to R will imply 3 1 must belong to R. 2 4 belongs to R will imply 4 2 must belong to R. Similarly 3 4 belongs to R imply 4 3 must belong to R. So AB belongs to R imply BA belongs to R. So R is symmetric. Next we will see that whether R is transitive or not. R will be transitive if and only if AB BC belonging to R will imply AC belongs to R. So this B will be eliminated and AC will belong to R. So here we will see that 1 1 3 and 3 1 belongs to R. So 3 will be eliminated, 1 1 belongs to R also. But you will see that 3 4 and 4 2 belongs to R, but 3 2 does not belong to R. 3 4 and 4 2 belongs to R, but this 4 is eliminated, 3 2 does not belong to R. So R is not transitive. So this is all about relation for basic conception, and it's also helpful for the beginners. And if you have any question or any doubt, please let me know through your comments. And there are many various types of problems in these chapters, and I will discuss these problems in my next video. So stay connected and go to my next video.